S-Chan presents Educational Video Lectures as per the new UGC curriculum. Difficult concepts made easy. Study anywhere, anytime.
The topic that we are learning is linear programming problems, and in this part of the video we will be starting the simplex method.
If you want to study this topic in detail, refer to these books from S-Chan Publishing and Vikas Publishing House. Link is provided in the description box.
Welcome to S-Chan Academy, and I am Anmol Bhatia. We are doing the course Business Mathematics, and in that we are learning the topic linear programming problems. In this part of the video we will be learning the simplex method. But I wanted to tell you that before learning this simplex method, you need to understand the basic concepts of linear programming problem and the graphical method. So if you haven't watched those part of the videos, you can refer to S-Chan Academy and watch the videos. So the topic that we are learning is simplex method. So firstly, you want to understand that why we require the simplex method. As we mentioned in those videos of the graphical method, that the graphical method is only applicable in the cases where the decision variables are only two. But in majority of the problems which are related to daily life, the two decision variables would not work. The decision variables may be many. So if you have more than two constraint or more than two decision variables, then the simplex method is useful. So it has a particular set of this methodology, and the methodology states that the simplex method requires that the problem to be converted into standard form. What is the standard form? I'll tell you in few minutes. Then all the constrained equations are to be converted into equalities. All these inequalities are required to be converted into equalities. But how can we do that? We can add, or we can no doubt add slack variables and subtract the surplus variables or the artificial variables, add the artificial variables into it in order to make it an equality. We'll understand this more in detail with the help of an example. Then there is a rule that the right hand side of each set of constrained equations must be non-negative. That means we need to have a positive value of the solution on the right hand side. If it is not, that means in the set of question you are having a negative value. So initially you have to make it positive by multiplying it with -1. Then the objective function should be of the maximization type. That means the simplex method is applicable, in our perspective, it is applicable to the maximization type problems. But if it is minimization type problem, that can also be solved. Okay, so these are the basic steps which are based on the simplex method. And mathematically, if I can say that you should have an optimization or the maximization or the minimization function. So here generally we have a maximization function which is z equals to, let's say, c1x1 plus c2x2 plus so on. This is the case, and these are the extra variables, maybe slack or surplus variables. We need to multiply them with 0 because they don't have any role in it in the objective function. And the constraint equations that you can see must be of equal to type. That equal to type can be done by adding the slack variables into it. So these are the basic expression of the standard form of the simplex method. So let's understand what is a slack variable and what is a surplus variable, what is an artificial variable in real sense. In order to convert a less than type or less than equal to type equation into an equal to type equation, we need to add a slack variable to it. Let's say for an example, I have a value which is 2x plus y is less than equal to 4. So as I've told you, for converting into the standard form, I need to add a slack variable into it. That means 2x plus y plus s1 equals to 4 must be my modified equation for changing this less than type constraint into an equal to type constraint. I'll tell you why we require this. Then if this is more than type constraint, or if it is a more than type equation, then you need to subtract an surplus variable and add an artificial variable into the particular set of equation. Let's say for an example, I have this equation 2x plus y is more than equal to 4. I have this more than type constraint. So what can be done? I need to subtract the surplus variable and add an artificial variable in order to make it an equality. So surplus variable is to be subtracted and a, that is an artificial variable, that is to be added. But if it is only equal to type constraint, then also we need to add an artificial variable into it. Now what do you mean by a slack variable? A slack variable is basically an unused resource, as the definition says. That means an extra machine which is there in the warehouse, or an extra labor which is there in the available with the company. Let's say for a case of let's say a faculty which is there in the university. You have n number of faculty members which are there in the university, but those faculty members are available in the university for a limited number of times or a limited number of hours, which is less than type constraint. Let's say I want to convert that less than type value into equality, into an equal to type constraint. Then I need to use a visiting faculty that might be my slack variable, and that slack variable is to be added into that particular set of the total number of hours to convert it into an equality. So that visiting faculty is a kind of a slack variable that is to be added into the set of equation in order to make it an equality. So that, as per the definition, either that unused resource which is lying in the company, that can be a slack variable. That might be labor hours, the money, or the warehouse space, or any number of resource which is there in the business problem, that can be termed as a slack variable. Surplus variable is an exceeding resource. If let's say this equation is more than type equation, that means those resources are exceeding your expectation. So we need to remove those additional or extra variables, which is additional, or the surplus variables or the extra variables that are to be removed, and an artificial variable is to be added. When we do certain problems in the upcoming slides, we'll understand it more. So a surplus variable is the amount by which the solution values exceeds a resource, and these variables are non-negative surplus variables. No doubt we are subtracting it from the equation, so that S value should be non-negative. That means the value of S should be positive value. Let's try to solve a 3-variable problem with the help of a simplex method. So as I have told you in the initial part of the lecture, that this simplex method is applicable to those problems which cannot be solved by the graphical method. That means the number of variables should be more than 2. So here you can see that the number of decision variables are more than 2. That means x1, x2 and x3, and it is subjected to certain set of constraints, and those constraint equations are only less than equal to types. So if the constraint equations are only less than equal to types, that means you need to convert them into a equality. So how can it be done? We need to add a particular slack variable into it so as to make it an equality. So the first step in applying that simplex method is to convert the original equation into the standard form. I'll come to this objective function in few minutes. But before, I should convert the constraint equations that I have. Let us look at the first constraint equation, which is 2x1 plus 3x2. It is less than equal to 8. So I need to convert it into an equality first as per the procedure. So 2x1 plus 3x2 plus s1 equals to 8. This is the first set of equality. And the second set of equality is 2x2 plus 3x2 is less than equal to 10. So I need to add a slack also. Here also I need to add a slack variable. So I can term those slack variables as s1, s2 and s3. So all these variables are added to that particular equation, and we are pretty much clear that all these variables are non-negative. So these variables are positive variables. Now what happens, the objective function which was given to me in the question, which was 3x1 plus 5x2 plus 4x3, that objective function should have the decision variables. Those decision variables are S1, S2 and S3. So apart from X1, X2 and S3, these can also be the decision variables, but they do not have any impact on the objective function. So I may mention here 0 S1, 0 S2 and 0 S3. So this needs to be mentioned. So this is the step 1, which is related to the simplex problem. Now in the step 2, what I need to do, I need to make a table, and that table has a fixed format. What is that format? I need to write CB, which is the profit per unit. Then variables, or you can say basis, and a solution variable. Then you need to write all the objective functions decision variables, which are x1, x2, x3, s1, s2 and s3. And above that solution you need to mention Cj values. What is Cj? Cj are the objective functions coefficient. So you have the first coefficient as 3, the second coefficient as 5, then 4, 0, 0, 0. So you need to mention in the table that 3, 5, 4, 0, 0, 0. These are the values of the coefficients that the decision variable has. And now if I look at the constraint equations are S1, S2 and S3. These three are my slack variables that I need to remove. So the main perspective of adding those slack variables are, I don't want those slack variables to be the part of my system. I want those decision variables to be the part of my systems. That means I need to remove these slack variables and put the decision variables on the slack variable case. So what is to be done? In the first equation you can see that you have all the decision variables, but apart from that you have a slack variable also. So you need to mention here slack variable number 1 as a part of the basis, then slack variable 2, then slack variable 3. Then what is the coefficient? Coefficient of S1, S2 and S3 from the objective function are 0, 0 and 0. So mention here 0, 0 and 0 because these are the coefficient of the slack variables. Then in the solution column, what is to be mentioned? In the solution columns, the RHS part is to be mentioned, which is 8, 10 and 15. So mention here 8, 10 and 15. So these three are to be mentioned. Then what about these elements? So these elements are from the objective, from the constraint equations. That means you have the x1 coefficient as 2, the coefficient of x2 as 3 and the coefficient of s1 as 1. So substitute the value, which is in place of x1 you need to write 2 because the coefficient of x1 was 2 and the coefficient of x2 was 3, then 0 in s1 is 1, then other variables were not there, so we have written 0. And for the second set, it is written 2x2 plus 5x3. That means 0x1 is to be mentioned also. So x1's value is 0, so it is 0, then x2's is 2, then 5, then 0, 1, 0. So in the similar fashion, you have mentioned all these coefficients. Now what is to be done, or what can be done now in order to get a particular solution? So you can see that some two elements are to be added, and those two elements are Zj and Cj minus Zj. Those two elements are to be added here. What is the use of those two elements? We will be finding a particular decision variable that is required to be entered into these set so that the final answer or the final solution may come. So what is Cj? Cj is the sum product of these two, which is the Cb values and these x1 coefficients. So that means I need to multiply and add. So 0 into 2 is 0, 0 into 0 is 0 and 0 into 3 is 0. So all three are zeros. So we need to add them and put it here. So I'll get a 0. Then next is 0 into 3 plus 0 into 2 plus 0 into 2. That would be 0 again. Then 0 into 0, 0 into 5 and 0 into 0 is 0. So I have added all these values. So no doubt we'll definitely get a 0 if all these coefficients are 0. So Zj values are 0 in this particular set of an example. And then you have the Cj values, you have the Zj values. So you need to subtract Cj and Zj, both these values. So 3 minus 0 would be 3, 5 minus 0 would be 5, 4 minus 0 is 4, then 0, then 0, then 0. Now what is the usage, or what is the applicability of Cj minus Zj. Cj minus Zj will tell you, the coefficients of Cj minus Zj will tell you that your solution is an optimal solution or not. If all the coefficients are 0 or negative, then your solution is an optimal solution. If not, you need to perform something or you need to iterate so as to get a particular optimal solution. So here, as you can see that you are getting positive values and 0. That means your solution, which is this solution, is not optimal. That means you are not having an optimal solution right now. So what steps have we done? Firstly, we have converted the functions, which is an objective function and a constraint equation, into a standard form, which is by adding the slack variables, and those slack variables are added to the objective function with 0 also, so as to get a particular set of equations. Now those equations are to be transferred into these set of matrix, and from that calculation we have found out Cj minus Zj. Now what is to be done from the Cj minus Zj part? Initially I have told you that these values should be non-negatives or 0. So here you have the positive value. So what we need to check? We need to check what is the maximum of all these elements. So here the maximum of all these elements is 5. So I have highlighted 5. So 5 indicates that these elements are the elements of a key column. So key column indicates that this decision variable is to be entered into these particular set of bases. So x2 is to be entered somewhere here, here or here. So I don't know where to enter or where should x1 to enter. So for that we need to calculate this minimum ratio part. Now what is this minimum ratio? Minimum ratio is the ratio of solution and the key column elements. So here the first element of the solution is 8 and the second element is 3. So 8 divided by 3 I have to write it here. 10 divided by 2 I have to write it here. Then 15 divided by 2 I have to write it here like this. So this I have written. As the name suggests, minimum ratio, so I need to choose minimum of the 3. So here you can see that this is minimum. That means this particular part is the key row. So I have got key column and I have got the key row. Now what is the usage of key column and key row? Key column will tell you that x2 will enter into this system and which slack variable will leave, that will be depicted by the key row. So key rows, first key row indicates that this is to be left. So that means S1 is to be removed from the system and x2 is to be entered into the system. So I need to make a new table in which S1 place is replaced by x2 and these intersection of the terms indicate a common value which is 3. So this 3 has to has a particular role in the simplex problem. So we stop here for a short break. In this part of the lecture we have learned about certain steps of the simplex problem, in which step number 1 was to have a conversion into the standard form and step 2 is making that table. Till now we have not performed the iterations. So after coming back from the break we'll continue with the same example and we'll perform the iterations on the same set of values.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on UGC curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting within the comfort of your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back after the break. Before going to the break, we have learned about the simplex method 2 steps, that is conversion into the standard form, and second is making the table. In this part of the video, we will be learning about iterating it because we have not got an optimal solution. So in order to get an optimal solution, we need to iterate the particular solution. So the solution that we got was to replace S1 with x2. So in place of S1, I have written x2 in the new table. So I need to make another set of table with all these values, and I have got a key element, which is the combination of key column and the key row. So key column and key row intersection element was 3. Now here it has a particular rule. What is that rule? I need to make that key column as 1 always, and the elements associated with the particular key column that are to be made 0. So I need to make these two elements as 0 and this element as 1. This is the particular rule of the simplex method. So what can be done to get this number as 1? So I need to divide the entire row by 3. So 8 divided by 3, 2 divided by 3, 3 divided by 3, 1, 0, 1 by 3 and 0, 0. So I've got 1, and what I need to do, I need to remove these two variables, which is 2 and 2, and I need to make them 0. This is the rule of the simplex problem. So this is the second row, and in the second row I want to get 0. So what row operation should I use? So the row operation that I'll be using is R2 new, it changes to R2 old minus 2R1. So these are the old elements and I want to have new elements. So 2 minus 2 times of this 1 would give me 0. Here also 2 minus 2 times of this 1 would give me 0. So this is the case. So what I need to do, I need to perform the row operation. That means 2 minus 2 multiplied by these elements and 2 minus 2 multiplied by these elements. So after performing the row operation, I'll get a new element, which is these elements are converted into the new set of equations. So that means minus 4 by 3, 0, 5 by 3, minus 2 by 3 and so on. Here also we have made a new table. That means the first table was the initial table and we have started the iteration part. Iteration means we are approaching towards an optimal solution. So here we got all the elements. What is the step? The step is to calculate Zj and Cj minus Zj. So Zj is what? Zj is the sum product of the elements of these two. That means 5 multiplied by 2 by 3, which is 10 by 3. 0 multiplied by minus 4 by 3 is 0. 0 into 5 by 3 is also 0. That means the sum of all these is 10 by 3. In a similar manner, for the next part is 5 into 1 plus 0 into 0 plus 0 into 0. That means the total is 5. So I have to write 5. Then for the next set, set of values, so Zj is calculated. Cj you have 3, Zj you have 10 by 3. So 3 minus 10 by 3 will give me a value which is minus 1 by 3. Then 5 minus 5 is 0, 4 minus 0 is 4, 0 minus 5 by 3 is minus 5 by 3, then 0, 0. Here what was our aim? Our aim to get all these elements of Cj minus Zj as either negatives or zeros. So here we have got this negative, this 0, this negative, these zeros, but this is problematic. So till now, till the first iteration, we have not got all these elements are zeros or negative. So we have to perform again one iteration in order to get an optimal solution. So what is that iteration or what can be done? So we need to find out the maximum of all the elements from Cj minus Zj column. So here the maximum element is 4. So 4 indicates a key column. That means I need to highlight this column and indicate that this x3 part is the entering variable. So x3 would be entering into this system that I want to remove. So here S1, S2 and S3 are my slack variables that I want to remove now. So how can I check that S2 would be removed, S3 would be removed or X2 would be removed? That can be checked by getting this minimum ratio part. What is that minimum ratio? Minimum ratio is the ratio of solution and X3 column, which is the key column. So 8 by 3 divided by 0 is infinity. We need to keep it blank because we don't use infinities and the negative terms. Then we have 14 by 3 divided by 5. That means 14 by 3 divided by 5. And 5 by 3 divided by 4. Sorry, 29 by 3 divided by 4. So 29 by 3 divided by 4, I'll get a value. So as the name suggests, minimum ratio. So I need to choose minimum of all these 3. So minimum of all these 3 is the second one. That means the second indicates the key row. So that should be highlighted also, and that indicates that S2 is to be removed. So I need to remove the S2, and in place of S2 I need to substitute X3. So here we would be doing the second set of iterations in which the table would remain same, and what is to be done? x2, s3 would remain same, but in place of s2, x3 will be substituted. So the new table would be like this: x2, s3 would be same, and in place of s2, x3 will be substituted. The rule was to have an intersection of key column and the key row. So the intersection of key column and key row is this 5. That means we need to make this 5, which is the key element, as 1, and above or below elements are to be made as 0. That means we need to divide this entire row by 5. So 14 by 3 divided by 5, this by 5, this by 5. So this should become 1, and this is already 0. So these two are not to be touched upon. So first row is not to be applied any row operation. The second row operation is divided by 5, and for the third row I need to look for an row operation. So these red indicates that I have changed, or I have written the elements of the new table. Now for this next set of elements I need to apply a row operation. What is that row operation? This is 4, and I need to make this 4 as 0, and I need to use this 1. So 4 minus 4 times 1 would be my row operation. That means R3 new, that means I want this new row to be made. So the third row, which is from the old table, minus 4 times R2 new. So this is my row operation. So I need to write all the elements and subtract these elements by multiplying them by 4. So I may get another set of variables, and here also what is required, all these elements are there in the table now. Now I need to calculate this Zj part and Cj minus Zj. As I have told you what is Zj and what is Cj minus Zj. So Zj is the sum product of the Cb part and the elements of the x1, x2, s1, s2 and s3. So 5 into 2 by 3 plus 4 into minus 4 by 14 plus 0 into 41 by 15. So I need to add them up. I'll get this value, which is 34 by 15. And in the similar manner, 5 multiplied by 1, 4 into 0 plus 0 into 0, I'll get the value 5. For the next set, I'll get a value 4. For the next set, I'll get the value 17 by 15, 4 by 5 and 0. Now, Cj minus Zj is the subtraction of both the Cj values and the Zj value. 3 minus 34 by 15 is 11 by 15. 5 minus 5 is 0. 4 minus 4 is 0. Then this is negative and this is also negative. So what we have done, we have reached to an optimal solution closely. So you can see that this is negative, this is negative, this is negative, this is also 0, this is also 0, but this is not negative, this is positive. That means we have to perform again one iteration in order to reach the optimal solution. So you can see the maximum of all is 11 by 15. So again the procedure is same. That means we have to choose the key column and we need to check whether the minimum ratio is, what is the minimum ratio? So 8 by 3 is to be divided by 2 by 3, which is this value 4. 14 by 5 is to be divided by a negative quantity, you will get a negative, so we need to keep it blank. 89 by 15 divided by 41 by 15, I'll get a value which is 2.17, which is minimum of all. So I need to highlight this row and mention it as a key row. So the intersection of these two is 41 by 15. So what I need to do, I need to divide the entire row by 41 by 15 in order to make it 0. And these two elements are to be made as 0 as per the similar procedure. So this is to be subtracted from this 1. So here, as you can see that I have divided the elements and performed the row operation, which is this operation, first row minus 2 by 3 times the third row, which is third row is the key row. And here also 4 by 15 times the R3 values. You can see from where these 2 by 3 and 4 by 15 values were there in the row operation. So you can see that this element became 1. So I need to use this 1 so as to make them 0. So in order to make this as 0, what is to be done? 2 by 3 minus 2 by 3 times 1. So 2 by 3 is your what row? R1, which is the old element, minus 2 by 3 times the R3, which is the new element. And here we want R1 new. So this is my row operation that I have got. Here this is already negative, so plus would come in that particular row operation. So here the row operation would be of the plus type, and after performing the row operation I'll get these elements which are highlighted in the red color. And also following the same protocol, you can see that x1 was the entering variable and s3 was the leaving variable from that key row. So in place of s3 you need to substitute x1. So you got all the decision variables here, and same procedure is to be followed, which is zj and cj minus zj. So here zj is to be calculated, which is 5 into 0 plus 4 into 0 plus 3 into 1, which is 3. Then 5 into 1 plus 4 into 0 plus 3 into 0, which is 5. Then 5 into 0 plus 4 into 1 plus 3 into 0, which is 4. And similarly for the other numbers also, then you need to subtract cj from zj. So cj minus zj will be 3 minus 3, which is 0. 5 minus 5, it's also 0. 4 minus 4 is also 0. Then again negative and negative. So what you got ultimately? You got all these elements as 0 or negatives. If this condition is satisfied, that means you need to stop your iterations. So here we have, I guess, done 3 iterations. So after 3 iterations, we have replaced all these slack variables with the decision variables, and we got a particular solution. What is that solution? We got x2 as 41 by 50 by 41, we got x3 as this, and we got x1 as 89 by 41. And what is the maximum value that can be obtained? That value would be 5 into 50 by 41 plus 4 into 14 by 15 plus 3 into 89 by 41. Add them up, we'll get this value of z, which is the maximum value. So need to write here itself the solution. So the requirement of the company was how many products are to be produced. So you can mention that the company may produce 89 by 41, obviously rounded off, and x2 would be 50 by 41 and x3 would be 14 by 15. And substituting all these values in the objective function, you'll get a maximum value. You can avoid substituting them in the objective function. Rather, you can get the value from the table itself, which is multiplication sum product of CB and the solution values. So multiply all these values, you'll get the value of z. So the z value is 256 by 15 as per the solution. So this is as far as your simplex method is concerned. So with this, we come to the end of this video in which we learned about simplex method, and we have taken an example of 3 variables in which we performed 3 different iterations to get a solution. Thank you.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.